Hey, MathCook here. This video contains one of many examples in my Algebra 2 library. The rest of those examples, along with hundreds of other videos, are only available at mathcook.com. Let's MathCook it up. This question says, the population of Boise, Idaho follows an exponential growth model. Starting in 1990, it took 18 years to double its population of 140,000. What will be the population in 2030? Round to the nearest person. So the population of Boise, Idaho follows an exponential growth model. So what is the equation for an exponential growth model? Here it is. So n equals n naught times e to the kt, where n is the final amount after t years. And t is usually in years. It could be in other units, but typically it's in years. N naught here is the initial amount, and e is a constant that goes on forever. So it's 2.718. And then k is a growth or decay constant. Now we know it's growth. If k is greater than 0, it's growth. If k is less than 0, then it's decay. All right, so let's go ahead and bring down our variables here and see what we can solve for first. It says starting in 1990, it took 18 years to double. So 18 years is the time for our first set of data here. And then they tell us that it doubled, and then the population was 140,000 initially. So that is the initial population, 140,000. So that's n naught. So we can put that here. And then if it doubled in 18 years, that means our final amount is going to be 2 times this. So 2 times 140,000 is 280,000. So our final amount is 280,000. Now we can use this information so that we can find k. So we're going to find k first, and then we'll be able to answer the question that they're asking. So let's go ahead and set up our equation and solve for k. I'm going to erase this chart here just to give us some more space to work with. All right, we'll bring down our equation here. So n equals n naught e to the kt. So let's go ahead and plug in. So n is 280,000. And then equals n naught, which is 140,000. Times e to the k, which we don't know, times t, which is 18. First step, we're going to divide by 140,000. On the right side, the 140,000s cancel. We get 2 equals e to the 18k. Next, we want to solve for k. The base is e, and notice k is in the exponent. So to be able to get k to the what I call the level playing field down here, we need to take the ln of both sides. The nice thing about taking the ln of both sides is that ln is really log base e. So let's see what happens here when we do that. So ln of e to the anything, these just cancel out, and it equals the exponent here. So let's go ahead and bring this up here. So on the left side, we'll still have ln of 2. So we'll write that here, ln of 2, and then equals. And on the right side, we have the ln of e to the 18k, which is really nice because the ln of e's just cancel out. So I'll put a little thing there. So we'll be left with 18k. And the rule we use for that, as a reminder, is log base e of e to the x, whatever x is, just equals x. And we can say that because the base and the argument are the same. So whenever the base and the argument are the same, they just cross out and it equals the exponent here, which is x. All right, so now we're almost there. We just need to solve for k. So we're going to divide both sides by 18. Now if we do this on our calculator, the 18s cancel, and k is going to equal 0.038508. This goes on forever. And we'll just round this number to 4 decimals because this is not our final answer. This is just going to help us eventually get our answer. So we'll go ahead and round to the 5. Notice there's a 0 after it, so the 5 will just stay a 5. So k is equal to 0.0385. So we'll use that k value going forward. So now they're asking us, what will the population be in 2030? Okay, so now let's rewrite our equation here. So they're asking for the final population. So that's our n value. So I'm going to put a question mark here. So we're looking for n. N naught is still 140,000, and that occurred in 1990. So that's really important. So that 140,000 is the population of Boise at the beginning of this problem, which is in 1990. So I'll put here 140,000. And then we now know our k value, which is this, 0.0385. So we can put that here. Now the tricky part is, what's t? So they want the population in 2030, which is how many years after the initial time year, which is 1990. So it's 40 years after. So that tells us we're going to plug in 40 for t to estimate the population of Boise, Idaho in the year 2030. All right, so let's bring down our equation here, and we will go ahead and plug in. So we'll have n equals n naught, which is 140,000, and then e to the 0.0385 times the time, which is 40. All right, so if you plug this in on your calculator, you will get 653,042 and a longer decimal here. All right, now we want to round this. Notice they say round to the nearest person. So we're going to round to the 2 here. So that means we're going to look at the number to the right of 2, which is 6. 6 is 5 or larger. So because that number is pretty large, that means we're going to round the 2 up to a 3. So when I said pretty large, I meant to say 5 or greater. So since the 6 here is 5 or greater, that'll round the 2 up to a 3. So our final estimate of the population in Boise, Idaho in the year 2030 will be 653,043 people. Hey Kook, if you found this video helpful, hit that like button, subscribe, and drop a comment. For unlimited access to all of my Algebra 2 videos, visit mathkook.com. Thanks for watching.